Okay. So yeah, this is the supply and demand assignment, and now we're working on number 5. Previously we ended with number 4. Okay. So I'll have Alex, Andrew, and Andy work on number 5. And then for number 6, we'll have Brian M, Brian O, and Keontae for number 6. And for number 7, we'll do Hung, Ryan T, and Shahib. Okay. And that's 5, 6, 7. And 8, we'll do Scott, Sharang, and Taylor for 8. And for 9, we'll do Wombly, William, and Zainab. Okay, so you all have your assignments. Go ahead and work on it for a few minutes, and I'll get back to you. And if you have like a question as far as getting started or something like that, you can ask it now, or anybody. You guys have read your problem, guys and girls. Anybody?
Do again.
What's that?
Ryan Tulip, which problem was I supposed to be on?
Well, let's see, Ryan. So 1, 2, 3. So Ryan, I think you're supposed to be doing number 4.
Oh, all right.
Okay.
And by 4, you mean question 8, right?
Oh, yeah. No, wait a minute. 1, 2, 3, 4. Yes, question 8.
Gotcha. Thank you.
Okay. Okay, so for number 5, Andrew, what do you think the answer is?
Well, I'm not sure the word for that, so I just wrote down the definition of the resolution type, and the thing is consumers maximum willingness to pay for a that's usually bought one at a time, like cars.
Yeah, you know, you're super quiet this morning. So let's ask Alex. Alex, what do you think the answer is?
I was trying to figure it out, but I wasn't quite sure how exactly to set it up, and I was just struggling to get started, to be honest.
Okay. And what about Andy?
I just gained access to the course yesterday, so I honestly have no idea how to do this because I wasn't able to attend lecture yesterday or Tuesday.
Oh, okay. Well, that should be resolved. And for you in particular, Andy, I have the lectures recorded, and I'm gonna post them on Canvas. I don't know if you saw the other stuff that was up there, but I have a YouTube channel that I upload all the lectures to, and there are also a bunch of like previous semester's lecture material there, and I think there's 2 playlists that are especially for this course that are broken up, and they're in the approximate order. So if you want to go back and review that stuff, you'll have the chance, and there's lots of other material on there. So to help you out with this kind of stuff, to catch up. Okay, so really, Alex, let's chat with you for a minute because you were here, right?
Andrew's also in the chat. He said he got 55.
Yeah. Okay. So that's good. So Alex, you know, the big issue here, right, is we have this definition reservation price, and so that's kind of where, if there's confusion, right, it's probably coming in. It's like you don't know the definition of reservation price as it relates to the supply function, right? Anyway, so I mean, am I right? That's the challenge. It's not the math, it's the language. Do you agree? Or
Yep.
Yeah. So, and again, like I said, this is kind of like a teachable moment in the sense that that's what a lot of you're going to find out. The math is relatively straightforward. It's figuring out what the question wants. That's really the difference in applied math disciplines like economics. Is the math you're going to be doing is, like I said, all the math that is standard, like undergrad, high school type math. But you know, in a math class, they'll just say something like, you know, tell me the vertical intercept, or tell me the value of the function when q is equal to 0, and you can just plug it in, right? They're just asking if you can do the math operations. But here, yeah, you have to bring that knowledge with you. So reservation price is one of the synonyms I told you all about in lecture for limit price. And so let's see, remember for question number 1, we had the limit price of, in that case, it's the buyer's limit price because it's the demand function. And now we're asking about the seller's limit price or reservation price. And, you know, it's the price at which the supplier reserves the right not to participate in the market anymore, where Q drops to 0. So you can see, hopefully now, that Andrew's answer was right. Okay. So you could think about it a bunch of different ways, but if you plug in Q is equal to 0, then you're going to get 55. And at a price of 55, that's the highest price at which they'll no longer participate in the market. And at any price below 55, their quantity supplied would also be 0, right? Do you agree, or do you have any questions?
Nope, makes sense now.
Okay, cool. All right, now we have our question number 16. Okay, and so this is Brian M, Brian O, and Keontae, and so what do you think, Brian M?
I got 14.5.
Okay, so you got 14.5, and you want to walk us through that a little bit?
Well, I just plugged in the price of 62 because you want to find out the quantity that would be supplied. So it's just plug in 62 into PV and then solve for QV.
Okay, good. And you guys probably noticed, and this is sort of a habit on Ignithium, we changed from QB to QV, and so for QB, that's the buyer's quantity, and QV is the seller's quantity. We don't use QS because which might seem more intuitive to use S for seller. Here we use V for vendor, which is like a synonym for seller. That's where the V comes from. But you're going to find out in just a little bit that sometimes there are conflicts between what the buyer wants and the sellers want to do. And for that reason, we need these little subscripts to differentiate between what's happening on the buyer side and what's happening on the seller side. So I think your methodology sounds pretty good, Brian M. What did you get, Brian O?
I got the same thing.
Okay, and Chiante.
Also 14.5.
Okay, so let's take a look. I'm clapping. Good job. Okay. Anybody have any questions? Okay. So now we have the question 17, and who's that?
Me.
Me? who's me?
Hong Lam.
Oh, okay, Hung. And I know you had at least one other person. We said Ryan was going to do question number 8. Did we leave you all alone? I know there was at least one other person. Okay. I guess I'm gonna have to start putting the
Professor.
assignments in. Yeah. Who's the other?
I could do it because I got a little bit late, so I could
Oh,
do
okay.
number 7.
Yeah. Okay, James. Well, so let's see. So Hung, how did you do this one?
I think like I got 78 for this.
Okay, you got 78. So and what did you do then? You just
I plug 4 into this and I get 62 plus 16. And I get
okay.
70.
Okay. And what about do you agree with him, James?
Just give me like 5 seconds.
Okay.
Sahib's in the chat and he got the same thing too. So
Yeah, I got
Okay.
78.
Okay. Good. Okay. Yeah, and so you notice here, in case you all had forgotten, but I mean, there's only so much information there. Hopefully this reminds you. But the value, or you might say the height, right? Because the value here, QV is the domain of the function. So Q is the domain of this function, and P is its value in the range, or sometimes we just say it's value, right? Which corresponds, when we graph it as we normally would, to the height of the function, right? So the y value, or the height of this function, is, for the supply function, it is the marginal cost. And I don't know, I'll ask you, Sahib, because maybe you could help me out a little bit with this. Does that make sense to you? Do you remember what marginal cost, the definition of it is? Sahib?
he says it's the cost of producing an additional unit.
Yeah, right. So what this says, and notice this is going to be an upward sloping function. So the cost of producing that particular unit in this case is 78, and our value on our units on the y-axis will be dollars, right? So it's gonna be $78 to produce the 4th unit, and the 5th unit will cost something different, and so will the 3rd unit. So marginal is one of those kind of tricky concepts we'll talk a little bit about in class. But if you have trouble at all with the word marginal, you can substitute in most cases the word additional for marginal. And so if you read this as, you know, what is the additional cost of producing the fourth unit, then you could get the same interpretation, and you get the same value the same way. Okay, any questions about that? No. Okay, so question 8, I know, I guess we have then Ryan and Scott and Shrang.
Yes, sir.
Okay, so how's this?
So it's just asking for the total cost, which is what we basically found before by just plugging in 4 units. So I got
But
78.
yeah, no, so actually not.
I could
Okay,
chime in too.
yeah, so remember the height of the function is the marginal cost, Ryan, okay, which is the additional cost, right? And this is asking for all 4 units. Do you see the difference, Ryan?
Oh, I'm sorry. So I had to add the previous 3. Right. I
Yeah,
remember that now. All right. I
yeah,
forgot.
yeah. So and who else was saying they could help out?
I can help out, Scott.
Okay, Scott.
So I actually did the same thing as Ryan in the beginning, and then I saw the assumed 0 fixed cost,
Yeah.
which means that this is long term. So then I realized that the price equals, it'd be the long term, that would be the average total cost, or MC.
Well, okay, so you're remembering stuff from principles, and that's
Mhm.
good. And we haven't covered this in lecture, but let me help just a little bit, because it's easy to misinterpret this. So see if this makes sense to you. So Ryan, you know, was on the right path. So you help me, Scott. You have the function written down, right?
Yeah.
Okay, so I'm gonna go back to the whiteboard and let's graph it. Okay, can you see the whiteboard right now, Scott?
Yes, Ken.
Okay. So here are axes, and this is why, you know, again, the more you get in the habit, especially unless the question is super straightforward, I recommend always graphing it. And then when you get to the exams, it'll be easier. So I just have an upward sloping supply curve here. And it's always a good practice to go ahead and put your axes labels. So QV, and up here, I'll put $/PV. And we know that our intercept is at 62, right? And we're looking at the value 4. Yeah. And then I'll use orange here. So it's a little bit more tricky than you would think. Okay. I'm just dumping that arrow over to the side because okay. So we agreed then that the height there
78.
Yeah, it was 78. So I'm just gonna put it over here so we don't get too much clutter on the vertical axis. But if anybody's confused, let me know. So we know the additional cost, right, of making this particular unit is $78, right? But it's asking for the total cost. And so if I was just to ask you in common, layperson type language, I was saying, okay, Scott, you're making widgets. And do you know what a widget is?
I don't.
It's so funny. Who said that?
I did.
Who's I can't see.
Oh, Celine.
Oh yeah. It's a
we have energy this
doohickey.
morning.
Yeah. It's a whatchamacallit. It's a thingamajig.
Okay, the plastic things.
Yeah, it's a something that's a nothing. Right. So it's just a general term. It's so funny because I had a student, I asked them, and they said very seriously to me, oh, it's an app on your phone. And they were right, because now on your phones, they have these little widgets that are like little apps. But widgets, a term that's been around since like 1750 or whatever. I don't know when it first showed up. But yeah, a widget is just a general idea for a product, product X. It could be whatever. It could be baseballs or baseball mitts or little tools or whatever. It's just a general. It's like saying a good, right? But so, and you'll see that term used a lot in economics for just like a general, call it whatever. So you're making widgets. You're a widget maker, and you've made 4 of them, right? And if I ask you, well, how much did that 4th widget cost you to make? You'll say, oh, it cost me $78, right, Scott?
Yeah.
And then I'll say, well, you made 4 of them, right? What was your total cost? Well, you're gonna add up your cost for making the first one, your cost for making the second one, your cost for making the third one, and your cost for making the 4th one, right? I mean, right?
Yeah.
So in our case, right, how would we do that? Well, this gets just a tiny bit complicated. And if you think about the complication, then you might get unnecessarily confused. But you're just basically adding up the area underneath the curve. And do you see that shape there?
Yeah, trapezoid.
Yeah, it's a trapezoid. So now, again, without being unnecessarily complicated, why don't we go ahead and calculate the area of the trapezoid? And now you remember, Ryan?
Yeah, I remember now. I forgot about total cost being, you had to make sure you added.
Yeah, right. And the reason why we say it's competitive markets and assume fixed costs are 0 is that if I asked you, well, what's your total cost of producing those 4 widgets, Scott? And it turned out that, I don't know if have you ever done any woodworking, Scott?
A little bit, not professionally though.
Yeah, me neither. But like back when I was a kid, they used to have a wood shop and metal shop, and in middle school and high school, and we would make like little signs and step stools for the home and other things like that. It was pretty fun. I'm actually kind of, I mean, now I never, thought about being a carpenter or somebody that worked with metal because most of my projects are pretty bad. I mean, my mom and my grandpa liked them, or at least they didn't have the heart to tell me that they didn't. but yeah, not, my highest grades were not in wood shop and metal shop. Even though I tried, I just that wasn't my thing. So, but the thing I loved most about like both metal shop and especially wood shop was they had all these cool tools. So we had a drill press and all these different types of saws and files and like all this stuff. So when you're working on your project, you just have all of this equipment at your disposal, right? And if you were making a wooden widget, like you're making little rocking horses or something like that, you might have here for the fourth unit, the additional cost, right, is 78. But if you had fixed costs, that would be like the costs of your equipment, right? Because your additional cost is you go down and you buy the material, right, for that particular thing. You're going to buy the wood, you're going to buy some glue, maybe some nails, and maybe you're going to finish it off with some paint, right? And so the additional cost of making that thing isn't going to include your equipment costs. Do you see what I mean?
Yes.
Yeah. So if I say, well, what's your total cost of making those four things? You might be tempted to say, well, the materials for that last one were 78, and now I can calculate the area here for, like all of the material costs, which we're adding up all the marginal costs, right? But if I ask you your total cost, then you might want to add on, the cost of the tools and stuff like that, because that's part of your cost too. But if we say that, and those equipment costs would be our fixed costs, because they're going to survive whether we, produce 4, we produce 50, that equipment's still going to be there. So that's what we mean by fixed. It doesn't vary with your level of output. So yeah, if we say we're asking for total cost, but we're assuming our fixed costs are 0, then we know we just have to add up these marginal costs. Okay, so I don't know if you all did it yet, Ryan and Scott, and I think Sharang wasn't on this too, but maybe are you for the next one, Sharang?
No, I was on number 8.
Yeah, you're on, and that's the one we're doing right now, right? Or
Yeah.
So did you have any questions, Sharang?
No, I'm following along. I did run wrong. So
Okay, do you all have an answer yet now?
280.
yeah,
So,
I got 2 as well.
280, right? Do we all agree? 280. So you all did this, I think. Tell me if I'm wrong. You did the area of a trapezoid times 0.5 times the height of the trapezoid, which is 4. And you got 280. Does that look right?
Yep, that's what I did.
Yeah. Okay. So I'm going to say that I agree with you all, but I do want to point out one other thing, and it's worth thinking about. Something else that you might be tempted to do, And so, and not that it's wrong, it's just, it kind of a little bit, might to lead to some inaccuracies in your calculations. So, okay. So we also have the first unit and the second unit and the third unit. Okay. So, and I'll talk to you, Ryan, because this might have been what you were first thinking. Do you see what I'm doing, Ryan?
Yeah.
So let's go ahead and, for sake of just doing it, right? We can go ahead and calculate the marginal cost for each of these 3 points. So I'll give the first one to you, Ryan, and then Sharang, you can take the third one, and Scott, you can take the second one. Okay. So what do you get for the first one, Ryan?
Uh, 66.
Yeah, 66. And what about the second one, Scott?
70.
70. And Sharang?
Would be 72.
I think it's 74, right? Because the slope is 4,
Oh,
right?
oh, right.
Okay.
Yeah.
So 62 plus 12 is 74. So that's maybe why you were thinking 72. But anyway, okay. So, so one thing we might be able to say is, well, the first one costs 66. Now, you all have calculators there, so to add this up, right? I mean, this might be, what we're thinking about, right? The first one is 66. The second one is 70. The next one is 74. And the next one is 78, right? If we add those 4 numbers, what do we get?
288.
288, right? And that's different. Well, what's going on here is that, notice, like, we start at 62, right? And then we go to 66. So the true cost of producing this first one is like all of these, and another word for marginal costs is incremental costs, right? So what we generally do in economics is we'll work with these smooth continuous functions like the linear functions as an approximation for a function that, and you may see this in your book. A lot of times they present this in Principles of Economics books. The book that I used for a long time did this, is these functions which look like, and I'll just draw it over here on the side really quickly, because it's not really a main point that I want to make. But they're these stair step type functions. So they go like this, and then like this, and then like this, and then like, oh, this. And then like this. Okay. And what we're doing is by taking an approximation of those functions, we're just like attaching the corners and creating our own function. Okay. But so I'll talk to you for just another minute, Ryan Turlip.
Yeah.
Do you see how, like, if we take the area under these stair step functions, we get these nice little rectangles or these nice little squares, right?
Right.
And so the area of that is going to have a width of 1, and then the height is going to be whatever the height of the function is. So if we did that here, and let's say 66 or 62 was the height of our function, we go like that, right? Then we're going to have just part of this area here, which is going to be width of 1 and the height of 62. That rectangle is going to have an area of 62. And we're missing like this triangle part here, right? But we could have started our rectangle, and let me move my arrow. We could have started our rectangle instead of at the bottom, right? We could have started it at the top. And if we'd done that, I guess.
Then it would be, we'd have a little more than we're supposed to.
Yeah, then we'd be like at 66, right? Yeah, then we'd be like here, right?
Gotcha.
But if you think about the area of the trapezoid, right? It splits the difference between those two, right? Basically, we're evaluating in between 62. See how we take the average at 62 plus 78 divided by 2. So this would be 62 plus 66 divided by 2, which is going to give us 64. So we're really splitting the difference, right, between doing a high estimate, and let me get my spotlight. So over here, we could do the high estimate, or we could do the low estimate. And if we take the area of the trapezoid, yeah, then we're splitting the difference, right? Do you see what I mean, Ryan?
Mm-hmm.
So anyway, that's why we end up using the area of the trapezoid, and it is an approximation, and it splits the difference between this high approximation and the low approximation of this like stair step function. So okay. I won't say anything more about it. If anybody is very curious, you're welcome to ask me in office hours. The one other thing I'll say about it is the nice thing about working with the continuous functions is that, you know, when we produce units one at a time, like I produce one you know, chair, and then another chair, and then another chair, right? We're assuming that we would say that goods are being produced in the word you might remember from math is discrete quantities. We use the word discrete when we can only take on integer values. But if you're talking about sacks of flowers or gallons of gasoline or something like that, for commodities, you don't have to produce in whole units. You could produce, or you could, you know, have 1.5 gallons of gasoline, right? And so these continuous functions, really what the assumption is that the goods we're dealing with are commodities. They can be consumed and produced in infinitely divisible units. Okay. And that's our leading case. And Again, if you want to talk about it in office hours more, we can talk about it. But there are very, very few instances or special cases where if we derive a conclusion from theory that's based upon the assumption that we're working with a commodity, that it would be the wrong conclusion if the good was a indivisible or a discrete good. So hope that helps. Anybody have any questions about that? No? Okay. So what I'm gonna do is go back here. Okay. And I'm clapping for you all. Okay. So you have to remind me that we didn't get down to question number 9, and I'm gonna stop for right now. Okay, are there any quick questions? Okay.